Now, these complex numbers Z1, Z2, Z3 are represented by the points Z1, Z2, Z3, Z4 on Argand diagram. Mark on Argand diagram, the points Z1, Z2, given that Z1, Z2 are roots of the equation of Z squared. Okay, so this is pretty okay lah. The first part to find the root, right? You should know how to find this. This one shouldn't be a problem. This one, just use Z is equals to minus B, which is minus root 3, plus minus B square, minus 4, A, C. Okay, so this is 2 times 1. Ta-da. So this is actually root 3 plus minus 3 minus 3 minus 12 will be minus 9 over 2. So this will be root 3 plus minus 3i over 2. So this is okay. Is it? Mark Argand diagram is Z1, Z2. Z1, Z2. They never say which is Z1, which is Z2. Right? Yeah. So just mark lah. So we have got here. Doesn't matter. For this kind of question, try and draw the scale lah. So use the same scale for both x and y axis. It'll be easier. Okay. If you're not drawing to scale, you probably cause a lot of trouble for yourself. So just try and draw the scale. Ta-da. Then what you can do is imaginary, and this is real. Okay. Not too bad. Then after that, you have root 3 over 2. Root 3 over 2 will give you about 0.866. This roughly 1.5. Okay, I'm just trying to draw like to scale. So this part here, what I get is 0.66. So this is root 3. What? I'll just draw 1 unit. So this is about 1 unit. Minus 1 unit. This is 1 unit. This is a 2 unit. This is 2 unit. So this is 1. 0.86 will be 1, 2, 3, 4, 5, 6. Root 3 over 2. About here. Half of it. I don't even know which is Z1, Z2. I think it doesn't matter, right? Yeah. So they want mark on Argand Z1, Z2. Okay. Just mark Z1, Z2 now. I'm just going to put this as Z1. There's Z2. Okay. Imaginary axis. Pretty great. Okay, so I'm going to show you the working. Find the complex number Z3, Z4, given that Z1, Z2, Z3, Z4 is a square enclosing the origin. So, okay. So there are two ways of drawing the what do you call it, the square, right? You can either draw it this way, means this is one way, okay, and then the other way of drawing it would be on the other side, which is here. Okay, so roughly lah, I'm not sure like here. So which one will be enclosing the origin? It's quite straightforward, right? It's quite straightforward, right? Is the one on the right, the left. So this is the one that you are looking at, this square here. So the question now is, how do you actually find Z1, Z2, Z3, Z4? I don't even know that because they never give you like what is Z3, Z4. You can I think either one would do. They just want Z3 or Z4. So just Z1, Z2, Z3, Z4 here. So you'll be surprised. This is nothing. It's not like no like fancy calculation involved actually. What you need is this one here because the length here is just 3 units. Okay, this is 3 units, right? So this one over here is also 3 units. Okay, so in other words, right, this one here will be root 3 over 2 minus 3 units. That's about it. And that's your answer actually. There's nothing. That's it. I know you feel cheated lah. So Z4 is actually root 3 over 2 minus 3 plus 3 over 2i. Okay, so that's it. So because it's 3 units, so you just minus 3 units over here. That's about it. Okay. So Z3, Z4. Z3 will be, it's just geometrical problem. There's nothing fancy there. Minus 3 over 2i. Okay, that's about it. Yeah. Yeah, so if this is Z1, Z2, if your Z1, Z2 is what you are labeling like mine, then this should be your Z3, Z4 lah. If your is the other way around, so means if this is your Z1 is below, your Z2 is above, then your Z3 and Z4 should be swapped. Okay. So that's about it. Then once you're done already, we're gonna do the one below. N84 paper 1 question 3. Wow, that's a I wasn't even born, man. Question. Oh my goodness. All right. Good. Um, and 84. Same thing. I want to do the geometrical one, which is part 2 lah. The geometrical one is important, so we have to do that. I'll just give you about 2-3 minutes to try. If you have any problem, question, please ask. Any question or problem you don't understand, please ask. Just text me. I'll give you time to ask. Some question. Oh, okay. That's a good question. So that's a good question. Fiona is asking, Mr. Gang, why cannot multiply Z1 by I so that the graph will move by 90 degrees? That's a very good question, actually. Okay. Let me explain to you why. Yeah, this question is important. So the question now is, why can't we just multiply I, Z1 with I, so that this will move 90 degrees? Okay. Now, just bear in mind, when you move 90 degrees is with respect to the origin. So that's the problem there. So if you move with respect to origin, you actually move 90 degrees with respect to the origin. It's actually a circle, which would be like here. Okay. So you add, so this will be like this is this length here. I'm not sure. So this is length here. This is 90 degrees, roughly lah. I need something like that. Okay. So essentially, right, what you're gonna do get is a circle around the yeah. Does it make sense? So you're getting a circle here, but you don't get a square. If you look at this 90 degrees, right, you don't get a square. It's a weird shape here. Does it make sense? Okay, to cut everything short is you multiply by I is relative to the origin, not to the shape of the curve. Yeah. So this is something which, but it's a good question. All right. So does it answer your question? Okay. Question please ask. Is it okay? Okay, I would want to do the subsequent one. We also don't waste too much time. I'll just give you some more time to try everything out. Oh, there's no answer for the one below. My goodness, why? Let's look at the subsequent one. I'll see what's the response. Well, the first one is pretty okay. A lot of you can able to do the first one. So I'm just going to do the first one quick. Shouldn't be too